Hello, my name is Chris Eberly and I'm an applications engineer at PLECS. I'd like to welcome you to this tutorial video on getting started with the PLECS scope. PLECS is a powerful tool for the simulation of power electronic systems and comes in two versions, as a block set for Simulink and a standalone platform. The PLECS scope is an integral component in both versions and is used for data visualization and analysis. During and after simulations, data results are displayed in the scope, and advanced zooming and built-in analysis tools allow a user to extract the exact waveforms of interest, as well as interpret the data for post-processing and reporting. The appearance of the PLECS scope is depicted here. The scope contains a plot area, an optional zoom area, saved views, traces, and data windows. We will now demonstrate the features of the PLECS scope using PLECS standalone. The scope component is located in the System library. To use the scope, drag the block from the library and drop it onto a schematic. The scope has a single green input terminal as the default is 1, but this can be easily changed. Double-clicking on the scope block opens the scope window. The main window of the scope can contain multiple plots. Plots can be quickly added or removed by right-clicking the plot area window and selecting Insert Plot Above, Insert Plot Below, or Remove Plot from the context menu. We're interested in monitoring the inductor current and load voltage waveforms of this boost converter and therefore require a second plot. We can start a simulation from the simulation menu or using the keyboard shortcut Ctrl-T and find that the scope immediately displays the two electrical waveforms. You will notice that the scope has a toolbar along the top under the menu names. Windows for these tools can be opened by clicking on the icons, or they can be accessed from the View menu. Several different zoom operations are available. The default setting is a constrained zoom, in which zooming is only performed in the X or Y direction. Zooming is done by clicking on the plot area and dragging the mouse horizontally or vertically until the desired area is selected. To the left is a free zoom icon, where the zoom area is defined by dragging the zoom cursor over a certain portion of the plot in both the X and Y directions. The third option is a zoom to fit, which will fit the entire waveform into the plot window. Every time a zoom action is performed, the view is stored in the view history. The previous and next view buttons allow you to navigate backwards and forwards through the view history. A zoom range can also be manually specified. Double-clicking on the X or Y axis opens a window in which the X or Y range of the zoom area can be entered. The user can also pan the view window in all directions by dragging the X or Y axes of the plot with the hand symbol that appears. The Scope Parameters dialog allows for the appearance of the scope to be changed and automatic or custom zoom settings to be applied to the X and Y axes. Clicking on the Scope Parameters button brings up a window where we can specify the number of plots and time range, as well as axis labels and plot titles, for instance. It is very easy to get a plot into a report by using the keyboard shortcut Ctrl-C. The image is now stored in the system clipboard and can be pasted into other applications. As can be seen here, the image size, appearance, legend, and resolution can all be customized. Now let's explore the other toolbar features. If we right-click on the toolbar area, we see several menu items. These are also available in the View menu. The Zoom Area window displays the entire waveform and highlights the zoom view that is displayed in the plot window. Constrained zoom and free zoom can also be performed in the Zoom Area window. The cursors are used for measuring waveform values and analyzing the simulation results. Clicking on the Cursors button will turn on a pair of cursors in the Plots and Zoom Area window. When the cursors are activated, the data window appears below the plot and displays two columns in which the time and data value of each signal at the position of each cursor are given. The plot titles and signal names are also displayed and can be modified by double-clicking on the name. A small icon that represents the signal type is shown next to the signal name in the Data View window. Signals can be of the continuous, discrete, or impulse type. The scope automatically determines the signal type from the port settings of the connected signal to ensure that the signal is displayed correctly. The signal type can be overridden if necessary by clicking on the signal type icon. Cursors can be positioned by dragging them to a specific time location or by manually entering a value in the time row in the data window. When the cursors are moved, they will snap to the nearest simulation time step. To place a cursor arbitrarily, hold down the Shift key while moving one of them. We are now able to measure values determined by the integration method of the solver between two simulated time steps. Note that the values in the data window will be displayed in italics to indicate that they are interpolated from the two nearest time steps. Right-clicking on the data view header line allows for additional data analysis columns to be displayed. The same options are accessible from a drop-down menu at the right side of the cursor button. For example, any combination of the difference, minimum or maximum between two cursors, the root mean square, and total harmonic distortion calculations can be performed. Each analysis is performed on the data between the two cursors. For meaningful RMS and THD values, the cursor range must be equal to the period of the fundamental frequency. Locking the cursors can be useful for performing measurements over a fixed time period, such as the period of an AC waveform or modulated gate signal. When dragging one of the locked cursors, the other cursor will be moved in parallel at a specified time difference. To lock the cursors, the delta option must be selected. The desired cursor distance can be set in the time row of the delta column. The cursors can be unlocked by double-clicking on the lock icon in the delta column. After a simulation has been completed, the resulting curves can be saved as a trace using the Hold Current Trace button. Traces are used to compare the results of different simulation runs. We can change the load resistance from 5 to 4 ohms and observe the differences in the waveforms. To access a particular saved trace, click on the trace name in the list. Saved traces can be renamed by double-clicking the name of the trace and reordered by clicking and dragging an entry up and down in the list. A trace can be removed with the red delete button. Traces can also be added and removed by simulation scripts for parameter sweep and efficiency type analyses, but this is a topic covered in a separate tutorial video. Existing traces in a scope can be saved by selecting Save Trace Data from the File menu. The saved traces can be loaded into a scope for later reference. Returning to the toolbar, a Fourier analysis of the data in the current cursor range is accessible from the Fourier spectrum button. The Fourier analysis window shows the magnitude of the Fourier coefficients for the given number of harmonics. The data range for the Fourier analysis is determined by the cursors in the scope window. By default, it is assumed that the cursor range covers exactly one period of the base frequency, though this can be changed in the Fourier parameters. Note that aliasing effects will be visible if the cursor time range is not an exact integer multiple of the inverse base frequency. The Fourier analysis window offers the same zooming and panning operations as the scope. The base frequency and number of Fourier coefficients which are calculated can also be set. Once we open the Fourier analysis window parameter settings, we can change window appearances and labels as in the scope. We can also set the scaling options for the Fourier coefficients as absolute or relative values and in linear or logarithmic relations. The Fourier coefficients can also be displayed with phase values in radians or degrees. In addition to data visualization and analysis, these two tools are also useful for reporting purposes. A right-click in the data window of both the scope and Fourier analysis shows a context menu. Selecting Copy to Clipboard copies the current contents of the table to the system clipboard. Afterwards, the data can be pasted into other applications such as a spreadsheet tool or word processor. The alternative method for capturing the plots in both tools is by right-clicking in the main window and selecting Copy. We can also edit the curve properties in the scope, including the colors, line styles, and thicknesses. By default, the curves for the different signals and/or traces in a plot are defined in the Scope Colors tab of the PLECS Preferences window, but these can be customized by the user. Here we can also choose to have a black or white background color for the Scope and Fourier Analysis windows. To change individual curve properties, right-click on a plot and select Edit Curve Properties from the context menu. To change a particular property, double-click on the corresponding table cell. From both the Scope and Fourier Analysis windows, a plot can be exported or printed from the File menu. When exporting, the plot style can also be changed and the output size of the image can be customized. When printing, the appearance of the plot and legend can be changed. Finally, to export an image of the schematic for documentation, choose the option from the File menu. PLECS allows you to export the schematic to a bitmap or scalable vector graphic image format or a PDF file. A second dialog lets you specify the export options for the specific format, such as the bitmap resolution. It is also possible to copy schematics to other applications directly via the clipboard. To copy an image of the current schematic to the clipboard, choose Copy as Image from the Edit menu in PLECS, then select Paste from the Edit menu in your target application. More detailed information on the PLECS scope can be found in the PLECS documentation included with PLECS and is accessed from the Help menu. This concludes our introduction to using the PLECS scope. Please visit our website at www.plexum.com for further information on PLECS. Our website also includes details on how to obtain a free trial license and pricing information. Please also check out our other videos on various topics of using PLECS, including thermal, magnetic, and mechanical modeling, writing C scripts, using steady state and small signal analysis tools, among others. Thanks very much for watching. Take care.